Hi, in this video, we will explore a continuous integration and deployment implementation for Boomi. First, let's see the typical life cycle of a Boomi deployment today. Here, a developer would build the process in the platform, test the process or integration by running it in test mode, create a package deployment that is stored in Boomi's internal repository. The package component is then deployed to a development environment and configured for extension. The integration test is executed manually or through an external test suite. Once the testing is complete, the package is promoted to production and configured for environmental dependency. Now let us look at continuous integration and implementation using Boomi. In this example, the developer would still build the integration in the platform. The integration would be approved by a lead, and the approval process would be triggered using a tool like Boomi Flow. Upon approval, Flow can automatically start a deployment pipeline using Jenkins. The Jenkins pipeline would first build the code, extract the component XML into Git, and perform static code analysis. Once that is passed, the service can be validated using external tools. The code would then be deployed to a QA environment and would notify QA testers using a communication tool like Slack. A QA tester can test the code and initiate promotion via Slack and a ticketing system like Jira. The pipeline can automatically then be promoted into production based on the status of the Jira ticket. Let's take a look at how the reference implementation is assembled. The reference implementation is built around the rich set of Atomsphere APIs. Boomi exposes RESTful SOAP JSON APIs that control every object and action of the platform required for automation. We then built a command line utility around the APIs to handle the orchestration, requests and response parameters, and manage exceptions. We then created a reference implementation for Jenkins. The Jenkins jobs leverage the CLI scripts to support pipeline orchestration for common Boomi actions such as package component deployments, process deployments, reporting, operations, and runtime installation. Finally, we wrap the CLI and Jenkins into a portable Docker container that can be deployed and configured to run in just a few clicks. Now we'll execute a quick demo to show the reference implementation. In this demo, I'm going to first run the CI/CD utility, configure the toolkit for an account, run a job to create a local runtime, extract account reports, call a Jenkins pipeline to deploy, test, validate, and promote a package, and finally perform static code analysis and extract a code quality report using SonarQube. I launched the CI/CD implementation using the Docker, and I'm going to log in to the Jenkins page. As soon as I log in, I see a folder with the name Boomi account Boomi. Now I'm going to configure this for my account. So I click on this, click configure. I scroll down to the account ID, and set my account ID right here. I'll leave the rest as defaults, hit apply and save. I click on the credentials and update the Boomi token for the account. And then save. Now I go back to the account folder and I see 5 tabs. The first tab has all the jobs and pipelines for package deployment. The second tab has all the jobs and deploy for legacy process deployment. Then I have a tab that handles the runtime installation, environment creation, and other jobs. I have a job for operations and monitoring, jobs that can toggle business statuses or change Boomi's schedules. And finally, a tab to generate reports of all kinds around the platform. So let me kind of click on some of these and just run a few reports to get details on my platform. So the first one I'm going to do is list all processes. I select build with parameters and I just give a wildcard and run the report to generate a list of all the processes in my account. It's completed. And I click on the process names report and I see there are 500 different components within my account. I have the component names and the IDs. This is a useful report. If I have to deploy components, I can just pick the IDs from here and feed it to the pipeline. Another report I can run is to fetch the list of all the atoms in my account and the environments in which they're attached to. Here's the report of all the atoms, the atom ID, and the environment in which the atoms are attached and the atom status. The next job I'm going to run is to install a local runtime. And I use this local runtime to deploy my packages to run unit testing, validation, and before I promote it to production environment. I click on install local runtime, build with parameters. I call the runtime Jenkins1, the default name, and click build. It takes about 40 seconds to run, but at the end of it, I get a runtime that's attached to an environment with the appropriate roles assigned. And that's complete. I open a new tab. I click on Publish Reports, go back to List All Atoms, and I rerun this query. And I see the new runtime created, Jenkins01. It's attached to the Jenkins environment, and the status is online. The next, I'm going to run a package deployment pipeline to deploy a package, run a test, validate the test process, and then promote it to the higher environment. I click Build with Parameters. I can either pass a comma-separated list of component IDs or a list of process names. I'm going to choose process name for this run. The package version to be created, I'll call 1.0. Notes. This is the test process that's going to be run to unit test the process deployment. It's going to be deployed in the environment Jenkins, which was just created, and it's going to be run on the atom Jenkins01. And after the test has been validated, it'll promote it to production, and it'll leave the status, the listener status is running. I'll skip the local environment deployment and creating the tag name for saving the code in Jenkins for the next test. And then I click build. First, it's deploying the packages to dev, and that's successful. Then it deploys the test process to dev. Once that's complete, it executes the test process and waits for 5 seconds and then validates if the test process has been successfully completed. And then once it validates the tests, it promotes the code to the next higher environment, which is production. Next, I will run a report to get a list of all the deployed packages. I click list deployed packages report and build with parameters, and I put the environment name as Jenkins and run the build and extract the build report. I see 2 packages deployed to the Jenkins environment with version 1.0 and with the notes saying demo for video. Jenkins also added a note on the user that triggered the build. Here it was triggered by the user admin. So now I know my packages are deployed and promoted successfully to production. I'm going to run one more test to end the demo, and that's to do a code quality report. Let me log into the platform and take a look at one process. This is a process that's called Sales Data Service. And when I take a look at it, it has a bunch of components that are marked as new. I click on the business rule. I see the error message is hard-coded. It's not parameterized. And I also see there's no description for the process. And finally, the exception shape is also hard-coded. It doesn't have the right parameters defined on it. Now I'm going to go to Jenkins and deploy this package and do a code quality validation. I run the job that says publish package to Git and Sonar and click build with parameters. I call the process name Sales Data Service, package version 1.0, and I'm deploying to the local environment and add some nodes. And add a tag name to store the package in Git. I see the build has failed because the Sonar quality gate had an error. I click on the Sonar cube and it says the quality gate status is failed because of an error. I click on the overall errors and I see 9 issues with the actual code. Sonar cube was able to determine all the errors, and I can click on it one by one, and it clearly says here's the first error. The component name shall not begin with new, and it marks it with a nice big red line and says that the map name starts with new map. I can go down the order and says here the process description for the process is not set. I can click on why this is an issue, and it says the description must not be empty. I can go down and see the business message does not have parameters defined. It's a hard-coded business message. The exception does not have the parameter defined. But it also determined some of the properties I have for my connector were not properly extended. In this case, the URL, the username, and password were hard-coded and not extended. So what this actually means is as this process gets deployed to higher environment, it'll still have endpoints and connectivity pointing to the lower environments like dev. And that's never good. So through the static code analysis, we're able to catch bugs before they actually can be deployed into a production or a UAT environment. And this concludes the demo. Thank you.